Hey everyone, welcome back to my channel. If you're new here, I'm Brian and I'm working on a multiplayer roguelite game in Unity. Today we're going to be talking about building story through gameplay. Up until now, I've mostly been focusing my game development effort just on getting the combat, level generation, and networking code working, so I've been neglecting the feel and style of the game. I've really been wanting to take a step back and work on adding story elements to give it more depth. Since roguelite games are intended to be highly replayable, a good story requires a narrative that takes dozens of runs to completely unfold. Games like Hades and Dead Cells do a really good job of having an overarching character-driven narrative or metagame to balance out the permadeath runs and keep the game engaging and provide a feeling of progression. I'm hoping to achieve something similar in my game as well. To start building up a narrative for my game, I decided to just experiment with a test story and see if I could actually create something. I'm not sure if I'll keep anything I built for this in the final game, but I learned a lot. I started off first by creating a storyboard to outline what I needed to build. The scene takes place in a forest. Through the forest is a path and there are flowers alongside it. There are two characters, I'm calling them Blue and Purple. The blue character is the main character and player controlled. The purple character walks along the path and gathers flowers. The blue player character follows along behind. When the purple character picks the dark blue flower, a shadowy fog appears and these magical spider monsters come out and start attacking you. You try to fight off the spiders, but you cannot do any damage to them, and the purple character ends up getting defeated. When it looks like all hope is lost, a mysterious wizard character appears and stops time. The player talks to the mysterious wizard and learns magic to fight the spiders. The wizard unfreezes time and the main character fights the spiders. When all the spiders are defeated, an evil sorcerer appears. You fight the evil sorcerer, and when you defeat him, your fallen friend is revived as a ghost and lights a path through the darkness. You follow your friend's ghost, and at the end of the light path is a portal. Now that I had a basic storyboard figured out, I wanted to get started on the 3D environment. I'm using Autodesk Maya here, and I'm just creating some simple planes to represent the forest path and add some variation to the grass color. I'm trying to keep the art style as simple as I can, focusing mostly on simple shapes and solid colors. The reason I'm doing this is I want my art pipeline to be really fast. If I have an idea, I want to be able to quickly sketch it up in a 3D software like Maya and then get it into the game with color and lighting and not spend days and days polishing up 3D models only to realize I've changed my idea and all that time I spent making a really nice 3D model is not actually going to be in the final game. One of the techniques I'm using to speed up the modeling process is just layering geometry on top of each other like you would layers in Photoshop. Now, this usually causes Z-fighting issues where the camera and renderer doesn't know which polygon face to render over the other one. So I'm using a special shader that I found on the Unity forum that lets you render geometry on top of other geometry by pushing faces closer to the camera. And what's nice about this is I can be really lazy when I'm 3D modeling. Instead of having to create like an airtight mesh where all the vertices are connected, I can just create meshes and overlay them on top of each other. So this really speeds up the modeling process. To create the shadowy darkness effect, I 3D modeled the pathway and then I faded the vertex colors on the edges to create a smooth transition. I then created a mesh border and emitted particles from that border in Unity. The rest of it is just cool materials with some UV animation and the overlay mode set to multiply. To create the 3D flowers in the game, I basically just used a polygon quad, stretched it upwards, and then cut a sphere in half for the main part of the flower, and then threw another cube in the center. And then I used the texture palette to assign different colors to the faces. Finally, I created a shader graph to animate some of the vertices to make them look like they're blowing in the wind. Next up, for the character art, I dug up some old 3D models I had created a long time ago as a starting point. For the player character, I found this old hero-looking apprentice model that I had built, and I just changed a few of the colors on his clothes and hair, but didn't make any major modifications. Then for the friend non-playable character, the purple stick figure in the storyboard, I found this character I had built a long time ago for a game, and I just decided to reuse it as is. Same for this character. This is the evil wizard sorcerer boss guy, and this was like a boss I was modeling for another game that I never actually created. Then for the mysterious wizard that appears and helps you and teaches you magic, I created this character from scratch, and I borrowed some inspiration from Kingdom Hearts Organization 13. I was a huge fan of this game as a kid, and I thought the character looked pretty cool. Now that most of the 3D artwork was created, I started focusing on the code to program the various actions that the characters would take in the game. To do this, I created a bunch of state machines and reused a lot of the ones I'd already created for the main game. So I already had state machines for combat and idols, but I added a bunch of new state machines for things like talking and searching for quest items and waiting for people and following way paths. And then I improved my code to make it so I could easily switch between and transition between different state machines. So for the forest friend character, which in the storyboard, she is the purple stick figure character that searches for the flowers and ultimately ends up getting killed by the spiders, unfortunately. This is her state machine code. And she has 3 states: searching for white flowers, searching for black flowers, and an idle state. And there's transitions between those states based on certain conditions. And the search for quest item state is actually implemented itself with its own state machine. So the search for quest item is kind of like a reusable state that a state machine can use, and it itself uses a search, move towards, and a harvest state machine with more transitions and stuff. So I like using state machines because the code is easier to maintain, it's more reusable, and your bugs are usually only on the transitions and not really in the actual state code itself, which is nice. And there's lots of good ways to test them if you ever want to get into testing. So I think visualizing what a state machine is actually doing through code alone is pretty difficult. So I like to draw a diagram or use like a visual editing tool to see my state machine. So that'd be interesting just to go over how the state machine for searching for the flowers works. So basically at any time, if this condition, the player being far away, is true, the idle state will be transitioned to. And if you're in the idle state and a player is nearby, we'll transition to searching for the white flowers. And if there are no white flowers, we'll transition to searching for the black flowers. And I didn't draw the lines, but this condition is checked every update of the state machine, and if this condition is true, any state will transition to the idle. So technically these searching states for quest item could also transition back to idle. Now the searching for quest item is also under the hood implemented with a state machine. And for this one, we start at the search state, and this basically checks around the game to see if the item exists that we're trying to find for our quest. And if that item exists, we transition to moving towards the item. And if the item exists and we're close by to it, like we're physically getting close to it, we'll transition to like the harvest or pickup state. And then if the item is null or no longer exists, we'll transition from the harvest state back to the search state. So we'll, if multiple of the items we're searching for exist, we'll start moving towards and looking for the next one. And that's basically how this state works. And because this state is a state machine, it can be interrupted by these other conditions. So if there are no X items, then this state will no longer get evaluated and it will go immediately to this state. And if the player is far away, this state will exit and go back to idle. For video games and movies, I feel like music and sound is one of the most important parts to building a good experience. I'm not very good at music, so for now I've mostly been using soundtracks that I've purchased on the Unity Asset Store and music that I found that's royalty free on SoundCloud. I also bought some footstep sound effects. In order to create an immersive sound experience, I wanted to change the footstep sound effects based on the surface that the player was walking over. To accomplish this, I'm casting a ray down from the character to figure out what color surface the player is standing on. And I have that color mapped to another texture atlas that determines what sound should be played on each pixel of the texture palette. The code for this is not too complicated. Basically, it's just a ray cast, and I find the highest priority material. Then I pull out the texture, I find the color based on the texture coordinate, and then I check a map that maps color to sound effects, and I play the appropriate sound effect based on that. For the events that get triggered in the game, I basically just created an interface called Cinematic and started implementing various cutscenes and cinematic events that I wanted to happen. All these are IEnumerator functions, which are just functions that can be paused and resumed across multiple frames. So it lets you do things like time and wait until certain conditions are met before you proceed with the next part of the animation. The actual code is pretty simple, and it's mostly just a lot of static calls to different game objects to spawn different things in the world and make updates to the game state. To add dialogue and conversations to the game, I integrated with this Unity asset called Dialogue System for Unity. And the reason I did this was this dialogue system is super powerful and it's used by a lot of really great games like Disco Elysium. And I figured there's no way I could write something as good as this in the amount of time I have. So I integrated it into the game and it was pretty easy to do, and I'm pretty happy with its capabilities. It lets you create conversations with like graphs where you can have nodes for all the different parts of the conversation, and it's easy to integrate with your own C# code to trigger events and reference variables. For animation, I recently started using this plugin on the Unity Asset Store called Animancer, and the reason I started using this was I was fighting and running into a lot of issues with Unity's built-in Mechanim animation controller system, where there was a lot of like state machine animation controls that I have to set up for each character, and it wasn't really reusable, and there were things I just didn't like having to create transitions for every animation I wanted to play. One improvement I made to the character animations was I wrote some code to normalize the walk animation playback speed to match the character's movement in the world. This helps the characters move more believably in the world, and it also lets me do things like frost and ice and slow effects that can slow down the animations based on how much of that stat effect is applied to the character. Here's what everything looks like all put together. Definitely want to increase the time it takes to pick up the flowers. Probably recognize that sound from Legend of Zelda. I'm gonna have to replace that before I publish this to Steam. Both characters use the same animation, so it looks a little weird. I'm pretty happy with how this transition to the combat and the shadow darkness came about. I like the music transition here and the kind of like animations all freezing and the particle effects stopping. I'm not sure if I'm going to keep this kind of typewriter sound effect as the dialogue is displayed in the actual game. This was just something I quickly programmed in to make the text a little more interesting as it's printed out, but I'm not sure it matches the aesthetic of the game. I like the way the evil wizard came out. Might increase the size of that character a little bit, and I also need to fix some of the animations because I noticed they're not always playing correctly. Pretty happy with how the particle trail for the ghost came out. I ended up parroting the particle trail renderer to the spine skeleton bone of the character, just to add some like natural waviness to the effect. Here I just put a portal to link it up to the rest of the game, but probably have it transition to like the starting like home base area. Yeah, overall I'm pretty happy with how it came out, and I think a lot of the systems and code and characters I started working on will make it into the final game. Thank you for watching this devlog. If you're interested in playtesting my game, please head on over to Steam and download the free playtest. I'll put the link in the description below.